Another definition that we're going to talk about is congruent. Congruent is just a fancy word for saying equal or same. So anytime you see the word congruent, we know that that is going to mean equal. And the symbol that we'll use a lot will be this equal sign with a squiggly line above it or a tilde. So this symbol just means congruent. So segments that are the same measure are said to be congruent. Angles that are the same measure are said to be congruent. So if you have measure of angle 1 is 40 degrees, measure of angle 2 is 40 degrees, then we can say measure of angle 1 congruent to measure of angle 2. So congruent means equal. All right, let's draw some pictures using our definitions. So we want to draw a line segment, so we know 2 endpoints is what we're looking for. So we have one endpoint, a line, and then another endpoint. And one of our endpoints is A, the other endpoint is C, it doesn't matter which one you put where, and B as a midpoint, which we know is going to be in the middle. So here's B, I'm going to draw it in the middle. This symbol and this symbol mean congruent, right? Our little dashes, so that's going to tell me that those are 2 equal lengths. You could also put a number there if you wanted to, which we will eventually. So it says if AB is equal to 5, so this guy is 5, what is the length of BC? Again, these are the same. Those little dashes mean the same. So that is also going to be 5. And what is the length of AC? Again, if this is 5 and this is 5, we just know that they're going to be added together, angle addition or segment addition, right? Because this plus this is going to be equal AC. So now we know that that length is 10. So 10 is our answer there. All right, let's draw another line segment. It says draw a line segment XZ. Again, we know it's an endpoint, so X one endpoint, Z is another. Now it says Y is in between. It does not say middle, so I'm just going to throw Y over here. And now it says if XY is 7, so this segment is 7, and XZ is 13, is Y the midpoint? Well, is Y in the middle? Do we know this? No, but we could figure it out. If the whole segment is 13, I'm going to take away XY, giving me 6. So that means YZ is 6. 7 does not equal 6, last I checked, so this is not midpoint. And your reason is just that. 7 does not equal 6. All right, moving on. Angle bisector, more review, can't get enough of it. So angle bisector, if a ray divides an angle into 2 congruent angles, then it is an angle bisector, right? So again, if I have an angle and then a ray with one endpoint and it cuts it in half, that is an angle bisector. And then this one, this angle is going to be congruent to that angle. So angle bisector divides an angle into 2 congruent angles. So if we look at example 6, we have which ray is the angle bisector? Well, which one is cutting the angle in half? It's pretty easy to see, right? I have P over here, and the ray is going off towards N. This is my angle bisector. That's cutting up MPR. So again, what is the ray's name? Well, the end point is going to be P. The line on the ray is N. So again, our arrow always points to the right. So PN is the ray. Given the angle bisector, what can I conclude? Well, it's an angle bisector, so we can conclude that this angle is the same as this angle. So more specifically, I can say angle MPN is congruent to angle NPR, right? Angle bisector, congruent angles. The last question says, if MPR is 90 degrees, what is the measure of NPR? Well, MPR is the big angle. So if the big angle is 90 degrees, we'll cut it in half because now I have 2 congruent angles. So 45 degrees is my angle measurement. Again, let's do some quick review on our triangles. We'll draw some pictures. So I want to draw an equilateral triangle. Equilateral, all 3 sides are equal. So I can draw a triangle and I can just put my 3 congruent dashes and now I have an equilateral. Isosceles, again, 2 S's right off the bat, so I know I've got 2 congruent sides. So this is isosceles triangle. The third one is scalene, all 3 different sizes. So I'll make this one 1, 2, and 3. Perpendicular lines, it's been a little while since we talked about that. Perpendicular, right? It's that upside down T, that's our symbol for it. It means 2 lines that intersect to make right angles, right? 90-degree angles. 2 lines to intersect 90-degree angles. A line segment with a midpoint, right? So again, if I have a line segment and it has a midpoint, it's in the middle, and these guys are going to be congruent. One more example. So it says B is the midpoint between AC. I have A here. I have C over here. B is the midpoint, so I'm going to put it in the middle. These are going to be congruent. AB is equal to 3x plus 5, and BC is equal to 6x minus 1. It wants me to solve for x and find the length of AC. Well, to solve for x, I know this guy and this guy are equal. So let's set them equal to each other, right? AB is going to be congruent to BC because of a midpoint. So I'm going to set them equal. 3x plus 5 is equal to 6x minus 1. So let's add 1 to both sides, giving me 3x plus 6 is equal to 6x. And then I can subtract 3x from both sides, giving me 6 is equal to 3x, and then divide by 3, so x is equal to 2. We're not done yet. We need to find the length of AC, so I'm going to plug it back into either one of these guys. It won't matter because they're equal, so I'm going to plug it into 3x plus 5, giving me 11. And so if 11 is 1, that means 11 is this guy as well. So 11 plus 11 is equal to 22 total units. So midpoint equal. Between, we don't know, but midpoint is definitely equal.